Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Alafana binti Sam. My matric number is AW250047. In this experiment 5, which is ideal gas behavior, I'll be explaining about what happened in our lab and the result and also the conclusion for this experiment. Yay! As for the introduction, the behavior of gases can be explained using the ideal gas law, where P is pressure, V is volume, N is the number of mole, R is the gas constant, and T is the temperature in Kelvin. In this experiment, carbon dioxide CO2 gas is collected using the water displacement method. Since the gas is collected over water, it contains both CO2 and water vapor. According to Dalton's law of partial pressures, the pressure of the dry gas can be obtained by subtracting the water vapor pressure from the atmospheric pressure, which is PCO2 equals to PATM minus PH2O. This experiment is used to determine the purity of commercial garden lime, which mainly contains calcium carbonate. When garden lime reacts with excess hydrochloric acid, HCl, carbon dioxide gas is produced according to the following equation. CaCO3S plus 2HCl in aqueous turns to CaCl3 aqueous plus H2O liquid plus CO2 gas. The volume of CO2 produced is measured by the volume of water displaced. Using the ideal gas law, the number of mole of CO2 can be calculated since CaCO3 and CO2 react in a 1:1 ratio. The amount of calcium carbonate in the sample can be determined. Finally, the percentage purity of the garden lime is calculated by comparing the mass of pure CaCO3 with the original mass of the sample. In this experiment, demonstrate the application of the ideal gas law, Dalton's law of partial pressures, and stoichiometry in determining the purity of calcium carbonate in garden lime. For this experiment, there is objective, which is to determine the percentage of mass of calcium carbonate CaCO3 in a commercial sample of garden lime using gas evaluation stoichiometry. For part A, accurate sample preparation and proper apparatus setup are important to obtain reliable result. In this experiment, a non-mass of garden lime, which mainly contains calcium carbonate CaCO3, was placed in the side arm flask. A 3 molar hydrochloric acid HCl solution was prepared to react with the garden lime and produce carbon dioxide CO2 gas. Second, all apparatus connections were made airtight to prevent gas leakage. Any leakage would cause a loss of CO2 gas and affect the accuracy of the result. The round bottom flask was completely filled with water to remove trapped air, which could interfere with the gas volume measurement. When the acid react with the garden lime, CO2 gas was produced and pushed water out of the flask into a receiving beaker. The volume of displaced water was measured and used to determine the volume of CO2 gas produced. This measurement was then used to calculate the amount of purity of calcium carbonate in the garden lime sample. For part B is basically just the same with the part A. So we repeat the same method. For part C, the purpose of this part was to measure the volume, temperature, and pressure of the CO2 gas produced. The water levels inside and outside the apparatus were equalized to ensure that the gas pressure was equal to the atmospheric pressure. Since the gas was collected over water, it contains water vapor. Therefore, Dalton's law was used to calculate the actual pressure of CO2. The equation is PCO2 equals to PATM minus PH2O. The volume of CO2 was determined from the volume of water displaced. To reduce errors, CO2 saturated water was used to prevent gas dissolution. Possible errors included in equal water levels and loss of displaced water, which could lead to an underestimation of the volume and moles of CO2 produced. So question 1, calculate the pressure of the CO2 collected for each trial. For the first trial at 22 Celsius, 1 ATM equals to 760 mmHg PCO2 equals to PATM minus PH2O. 760 minus 19.83 resulting 740.17. So 740.17 uh, over 706 resulting 0.9739 ATM. For the trial 2, we repeat the same formula using 23 Celsius, which is 21.07 mmHg. So we use the same formula resulting 1.9739 ATM. For the third trial at 23 Celsius, we repeat using the same formula and resulting 0.9739 ATM. So for the 1, 2, and 3, we resulting the same value. Question 2. Determining the percent by mass of CaCO3 in the garden lime sample. So, we will have the balance equation CaCO3 solute plus 2HCl aqueous, resulting CaCl2 aqueous plus H2O liquid plus CO2 gas. So, mole of CaCO2 equals to moles of CO2. So we use the formula N equals to PV over RT. We we put the value for trial 1, 2, and 3 uh, inside the formula. And for trial 1, we got 1.4026 gram per mole. For trial 2 and 3, 1.7411 gram per mole. And we calculate the percentage by mass of CaCO3. The formula was percentage by mass equals to calculated mass of CaCO3 over total mass of garden lime times 100. So for trial 1, we got 28.17, trial 2, 29.15. Same goes with the trial 3, 29.15. For question 3, relate this experiment with ideal gas behavior. Proper formula may assist in the explanation. The primary mathematical framework connecting this experiment to ideal gas behavior is the ideal gas equation, PV equals to nRT. In this equation, P represents as the pressure of the gas, V volume, N is the number of mole, R is the universal gas constant, and T is the temperature. By measuring the volume of water displaced by the gas and recording an ambient temperature, the ideal gas law allows for the direct calculation of the exact number mole of CO2 gas produced by the chemical reaction. Furthermore, because of the carbon dioxide gas is collected over an aqueous environment, it is not pure, it exists as a mixture containing both CO2 and water vapor. This experiment utilized Dalton's law of partial pressure, which is fundamental properties of ideal gas mixture. This principle states that the total pressure of gas mixture PT is equal to sum of the individual partial pressures exerted by each gas independently. PT equals to PCO2 plus PH2O. By physically aligning the water level inside the collection flask with the level in the external beaker, the total internal pressure PT is equilibrated with the atmospheric pressure PATM. Since ideal gas behavior It detected that the gas component do not interact with one another. The vapor pressure of water pH2O can be cleanly subtracted from the total atmospheric pressure. This isolating step yield the true pressure exerted solely by the dry carbon dioxide molecules PCO2, which is and then substituted back into the ideal gas law to determine the mass of calcium carbonate CaCO3 that reacted. Question 4. Suggest another material which can be used to replace garden lime. We suggest marble chips because they contain calcium carbonate and it is easy to handle. Question 5. Include statistical analysis in the calculation. So at the table, I already said here for trial 1 to 3, percentage of CO2 0.9739 atm. For trial 2, 0.9723 atm. And the third will be the same 0.9723 atm. Percentage of Ca2CO3 15.20% for trial first. The second and third will be 29.16%. Statistical analysis for the mean, we total all the percentage of Ca2CO3 divided by 3. We got 24.17%. For the standard deviation, we got 7.79%. And relative standard deviation, we got 32.23%. The conclusion for this experiment is the experiment successfully measured the volume of carbon dioxide CO2 gas produced from the reaction between garden lime and hydrochloric acid. The recorded gas volume, sorry, the recorded gas volume were 100 ml, 185 ml, and the same one for the third one, 185 ml at the temperature of 22 to 23 Celsius. Trials 2 and 3 show consistent result, indicating good precision. The lower volume obtained in trial 1 may have been caused by gas leakage, incomplete ration, or measurement errors. Since the temperature remained nearly constant, its effects on the gas volume was negligible. Negligible. Overall, the experiment achieved its objective and demonstrate the application of ideal gas law in determining the behavior of carbon dioxide gas. That's all from me for this experiment. Thank you.